Welcome to Introduction to Residential Microgrids. Great to have you here today to join this class and learn all about the latest advancements in microgrids. My name is Jen Mallett. I'll be your instructor today. I'm the CEO and founder of Level Up Automation. We are a smart home integration company. And I've been in the industry for 25 years and also am a smart home CEDIA CE provider. And what that means is we teach and are able to provide credits for a number of organizations like the AIA and ASID, among a few others, along courses that are really high technology to keep everybody up to date. So things like lighting controls, smart energy, and microgrids like this particular course, all the way to hiding technology in the home and extending it outdoors. So welcome. We're really excited to get started today. Just a little bit about Level Up Automation. As I mentioned, we are essentially technology architects for all of you. We design, install, and service smart home technology. I franchised my business about 5 years ago, and we operate in 10 U.S. markets where we work with architects, interior designers, clients, electricians, builders, you name it. Anybody who really wants to bridge the gap and have a specialist work on home technology. So a little bit about AIA CES class registration. This particular course was built for the Consumer Electronics Show and in partnership with Savant, which is a home integration brand that specializes in a number of really sophisticated systems, but one of them is power. And they put together the content for this class and got it accredited. So this is one HSW CEU value for the AIA. If you are attending, we'll make sure you get credit. A little bit about the presentation. This is copyrighted. It's protected by copyright laws in the US, so it cannot be shared or redistributed without really Savant's permission. What are our learning objectives today? Well, they're really fourfold. First is really to understand what's happening. There's a lot happening with electronic vehicles and microgrids and home battery options. There's a lot of movement and it continues to move fast. So our goal today is really help you understand what this landscape is like today within the homeowner experience and also help you understand where it's heading. We're going to help you understand how to identify the value of microgrids and take it really beyond just a term that people use to really understand what that means within a property design. We're also going to talk about how you can become familiar with main components and functionality of a residential microgrid. There are a lot of acronyms. There are a lot of parts and pieces that we're going to simplify for you and explain exactly what they are, when they should be used, regarding the right application. And lastly, we're going to cover really what the critical data is required to initiate one of these projects. This is certainly a specialty, but when you work in the right guidelines and within the right people, it absolutely is a fantastic ability to manage energy within homes. So the home energy landscape, we'll start with, really where we are today. There has been a considerable amount of grid modernization over the last couple of years, but we're really just getting started. There's going to be a lot of work over the next 5 to 10 years, helping us really take in the US an older grid and modernizing it to the needs of today. We have all been within understanding that in the news there have been floods, there have been large storms, and that our infrastructure in terms of power is really important to how we live our life. And power outages are continuing to increase, and they've doubled in the last 20 years. So related to that modernization of the infrastructure, it's really critical that we do modernize it and also look within our specific homes to understand how can I maximize the energy use or create a microgrid for my residential property. There have been a great growth within for EV Electronic vehicle sales, they'll continue to grow. About 15% or 22 million US homes will have solar by 2030. So that is also a growing energy independence monitor we look at. And then a third of all solar systems in the US have battery storage today, which is a place where that energy coming in from the sun is stored locally. And then how it gets used is really the next step, how and why, right? So we'll talk a little bit about that soon. And then this is about to end the Inflation Reduction Act of 2022. A lot of news outlets and probably political commentary around this that we won't get into, but generally speaking, the tax credit did start to really kind of infuse some investment in this area as it relates to home energy efficiency. While those will likely end by the end of this year, this is really a movement that is going to continue growing within the residential space and the commercial space as well. So what's happening? Our grid is under pressure. It is under pressure. So what you'll notice when you're looking at your energy bill is that you are paying for a rate. And the rate really has to do with whether or not you're in a peak service time or an off-peak service time. And peak service time, as you can see from this chart over on the right, is generally between 4 to about 9:30 at night, 10 o'clock at night. And what that means is that when everyone gets home from work, kids are home from school, that's when everybody is at home, cooking, watching television, doing the laundry, and putting a lot of stress on our grid. And as part of that, one of the ways our infrastructure manages that is by higher cost, hoping that people will maybe minimize their cost, their usage rather, during those peak hours, because it's putting a lot of stress on the grid. And then off peak, where it's less expensive to essentially use your electricity in your house and charge your car and things like that, you can see from this chart, it's almost half as much. So it's quite considerable. And there's a lot of different ways that we can manage costs and manage energy usage within a microgrid system. So there are really three different ways. So proactive approach around how to manage utility. There's planning, there's virtual power plants. There's some shared of energy resources in different parts of the country. And there have been incentives for home solar, energy storage, and EV charging. And the reason why is that peak number that you see there puts a lot of stress on our older infrastructure. And by having home solar, local energy storage, items like that, it really helps take the stress off the grid. For real-time management, what you'll see with utilities is they're, essentially managing demand response or time of use pricing, which I just spoke about. So off-peak and peak pricing is called TOU, time of use pricing, and your energy is more expensive when the grid is mostly taxed, and that's at the peak time. And then lastly, our utilities really try to help with energy management in terms of when there are blackouts, there would be rolling blackouts, rotating outages. Electricity is pretty much a requirement for most of us in terms of having a safe and healthy home. So there's some energy management that utilities have that kind of help essentially manage that grid during different times. So if we, for example, are in a heat wave where there's a lot of people using air conditioning units and the grid is really maxed out, they may use one of these emergency management tactics here to manage our grid, which is under pressure. So microgrids, why are they important? Microgrids really are a path to energy independence at the individual home level. So a microgrid is defined as a group of interconnected loads and energy resources that act as a single controllable entity with respect to the grid. So what that means is that we have the grid, right? Our utility coming into the house. How we manage that load coming into the house and the energy resources that we add onto the grid, whether it be solar or home battery, A microgrid type of approach really takes all of those elements and puts them together to make it more manageable and more powerful. So the microgrids really connect and disconnect from the grid to operate in like an island mode or a grid connected mode. And we'll talk a little bit more about that in the upcoming slides. The end result here is really more energy independence at the local home level. And also an ability to really be more resilient when the grid is disturbed. So if there is a large power outage because of a giant storm, for example, how that home is able to operate without power is very different in a traditional home versus one that has a microgrid and is allowed to have lights on, maybe do laundry, a whole variety of different things. So this is a high-level view of what a residential microgrid looks like. So you can see here we've got the utility grid. That's your utility company that you pay, likely monthly. In a microgrid setup, that would be one source of power. Above that, you see local power generation that also is an input into the microgrid. You might also have an automatic generator. You might also have a vehicle to home, which is an electric vehicle, which has essentially the ability to also take the battery within the vehicle and act as a backup to the home's energy system. So between local power generation, which is typically solar, the utility grid, the automatic generator, that a number of people have, and then EV charging when there is a vehicle that has the vehicle to home capabilities. All of those different sources can work within a microgrid interconnection device to convert it into the right type of energy that can be utilized at the home. And then once it's at the home, what you see over here on the far right of your screen is really load management. So once you have the sources in and you've got essentially the design here, then it's about how the homeowner really controls their load management. And whether it be a smart thermostat, which many people are familiar with today, or some smart appliances, or really next level, which is a smart electrical panel with a software behind it that really brings all those pieces together and allows you to create scenes and modes depending upon the power situation of the current day. So this is high level. We're going to dive deeper in here to go through some of the different components of it. But at a 10,000 scale foot view, you've got essentially energy sources, the sun, utility, your generator, possibly your car. You've got a microgrid device and design that's converting and making sure this energy is accessible. And then you've got the load management piece, which is, you know, how and when do you provide power to different everything really in your house, from like a dishwasher to a television to your lights to your heat. Why invest in a microgrid? There's a couple different aspects that are making it more and more attractive for people, either in existing homes, but also new home construction. You might see things like net zero houses or passive houses becoming popular. This is really, in addition to that, a great way to be able to manage the power within a place, because primarily it helps you with the sustainability of the property. So it gives you essentially an ability to have energy when you need it without having to rely on the grid. There's also some green motivations as noted here. So it helps you save money by eliminating excess use of energy and reduce your carbon footprint. We certainly all know that if you have any teenagers in your house or kids, they might be leaving lights on. Now that can be, you know, essentially addressed through smart lighting controls and other things. This is really that next level of, okay, when you look at lighting, temperature, appliances that are being used in the house, whether or not you're home or not, what time of year it is, what time of day it is, as we talked about earlier, all of those things really kind of factor into sustainability and savings. And a really well-designed microgrid and software platform with it is going to make it easy for you to be able to control. Energy security, this is increasingly, as we started at the top of the course here, important. We're seeing major weather events. And energy security and independence can be achieved through great planning and the right equipment. There have been escalating weather events, rolling blackouts. Certainly some of the benefits are peace of mind that, you know, your microgrid in your home is separate from others around you, which means that when the grid is down, you have that capability to keep your lights on and things like that. So it leads to really extended security and comfort and peace of mind. The last note here, it calls for dirty power. And a lot of people don't know that power that's coming in to your house, really, there's a lot of things going on with that. It's not just a straight stream of power that's coming in a certain level. It's actually, it can fluctuate. You can have clean power. You can have sometimes what's called dirty power, which means there's a lot of variance within the power coming into your house. And things are impacted by that, particularly electronics. So one of the great things that a microgrid does through part of the parts is it makes sure that, you know, if you're having energy surges or other things happening, that your power is coming in clean and all your electronics and appliances and things in your house are going to last longer because they're not having to deal with the ups and downs of what is called dirty power. Why invest in a microgrid? This is the third reason, economic savings. Certainly this is a big part of it. There's a lot of different net metering programs that are out there. We talked about peak shifting earlier. So a good example of this is with an EV electronic vehicle and a charger, right? Many people know that when you plug your vehicle in when you get home from work, you're going to want to set that EV charger so that it starts charging at 10, not 6 o'clock. And the reason is related to the chart we saw. It's about double the cost to charge your vehicle during that peak time. So peak shifting is one really, really great way to help with economic savings. There's also some decrease in cost of solar and storage over the last 5 years, considerable savings. It used to be really, really, really cost prohibitive for most people. And it's come down quite a bit over the last couple of years. And there's state and federal incentives that are out there that are continuing to be active for people to help make it more affordable. So this is federal incentives. Some of this will stay, some of it will go. We won't spend a lot of time on this, but they're really because of all the stress on our infrastructure and our grid, government entities have started to say, okay, we need help of the actual homes, and the ability to have a microgrid and have more energy independence locally is good for government, because then during those peak times or during those big outage times, they essentially are able to service people better because they have a number of people, maybe it's 5%, maybe it's 10% in 10 years, that are able to have energy independence, allowing them to essentially be without the grid for a little bit. And that helps everybody. So the microgrid at work. So this is another kind of version of the slide we looked at earlier, but it actually uses a home, which I think is really effective. So on the left side here, you can see this house, and you'll see that there are lighting loads, there are appliance loads, and there are circuits, as well as an electronic vehicle. So all of those things need to receive power. So you've got the utility grid, which is there, which has the X on it. You've got an or energy storage system, which we call ESS for short. You've got something called an automatic transfer switch, which we refer to as an ATS. And with the grid energy storage system coming in, whatever that is, those pieces that really are providing the power, bring it into an automatic transfer switch so that energy can be converted and able to use. Then it goes down to really flexible load management, which you see on the bottom here. And depending upon what is needed and how that particular electrical panel is set up, it is designed around that so that the ATS can deliver in that energy and it can be used. Whole home battery storage versus battery backup that is partial. So a key component of energy storage system, ESS, one is the smart hybrid inverter. And this is what manages the available power in the home. It is measured in kilowatts real time. So that is an important piece of an energy storage system. The battery storage, which is separate from the inverter, essentially is that scalable energy reserve. So in terms of home batteries, oftentimes what we do is if somebody starts with a partial home battery, it might provide 20 kilowatts of battery, right? But if you have a fuller, more full system, then you're going to be able to essentially get more time, more energy out of the time you have. And there's some mathematical things that we'll look at in a slide or two, which will just kind of help frame this for you so you can understand. There's some math involved where you're going to want to look at what you need from an energy perspective, and then how long you're going to need it for. And then really what that translates to is really the size of the battery storage that you have. Not all partial backup solutions are created equal. They're typically limited to 100, 200 amp applications. They have lower off-grid power, so they might be only have, for example, 3.5 to 9 kilowatt available, which is 14 to 33 amps. So it's not that powerful of a source for you. So there's lower battery capacity as well, which means that when the grid goes down, you might not have more than, for example, maybe it's 2 or 3 hours of runtime for your devices, which is not all that powerful and not really much more beneficial than just having another energy source available to you, like a generator, for example. So on-grid also can be limited, where you can't pass 200 amps, and most homes really are 200 to 400 to 600 amps that are part of that home. So partial backup systems have good uses, but at the end of the day, only part of your home is going to have backup. So it's not quite a microgrid, full microgrid solution. It would be more of an addition to a generator that provides some time when there is an outage. So the way partial backup systems work, you've got the grid over here. You're powering your partial back system, which is essentially a battery, right? The system uses an external ATS, which is that transfer switch part we talked about, and it can mimic generator-like performance in terms of how long it's able to provide you power. But as we mentioned earlier, there's some limitations to it. And essentially, the normal input line that you're seeing here for the backup solutions, you're really utilizing, for the most part, that normal input and then switching over to the partial backup system when you have essentially an outage, so an emergency input. So it's not, your partial backup system is not always a running part of your home energy solution. It's really only used when there are emergencies. Those can go into a smart load center where we've got critical loads here. In this graph, it's an oven and also some appliances that are there that you're going to need to keep going, water heater, things like that. And then you're able to identify what non-essential loads are. Non-essential loads may be the living room television or lighting in certain areas. The essential loads are going to be things that you're really worried about, like a freezer or refrigerator without any power. We've all probably had that happen and know how inconvenient that is. I went the wrong way, sorry. So this is an example of what things look like in terms of a home battery type of situation. As you can see, there's 2 units here. So one of the things that's really great about designing microgrids and designing around smart power is on the battery side of it, you can really plan long-term around how much power you're going to want to supplement with your grid, whether it be 100% or partial during outages. Home batteries are really effective along with the other tools we talked about in terms of building over time, because they are certainly investments. They're not inexpensive items. They're investments in your home. So what's really nice is that they are modular and you can build at them over time. So let's talk about really the whole home solution and what that looks like. And you can see that the setup of this particular chart is different than the previous one. One I'll call out is that your normal input and your emergency input are different. They've swapped, right? So in a situation where you truly have a whole home solution that's providing a microgrid, your scalable storage really is your normal input. So you are, for example, I'll use this example. Let's say you are looking to essentially cut energy costs for your home. Well, one of the things you do is for the scalable storage, you would essentially set it up so that you are storing those home batteries off peak. So let's say from 10 p.m. to 6 a.m., your smart energy system is loading up the batteries of what was used for the day. And then when peak comes along, right, you are not paying what would be essentially time of use, right? Because in this particular situation, you're only drawing from the grid when you have an emergency. You're using your scalable storage solution to essentially provide you power, cheaper power, when you need it. And that really becomes your normal input. Once you kind of go through that, you can see the smart load centers, and those look like electrical panels, which they are, but they're smart electrical panels, and we really refer to them as smart load centers. And a really good example of this is a number of people use generators for power backup, right? So when you have a generator installed at your house, one of the things you're going to need to decide are, what are your critical loads? Your electrician is going to want to know, what are your critical loads? Because once that generator is tied into those critical loads, your choices are done, right? In a smart load center, that restriction goes away completely. So a smart load center essentially takes the input of power and then provides the control about when power goes down, how are you going to use that power? What are you going to use it on? For how long? So that you can essentially, you're not fixed to a couple critical loads. Everything is a load that you can control in your house through your phone. So it's very, very powerful and really is the future of energy in homes. We're going to talk about incorporating additional local power sources. And solar has been growing dramatically over the last 5 to 10 years. Solar is fantastic, great way to essentially supplement your home energy. But that's energy coming in, as we've talked about earlier. It's kind of all about the brains of what you do with that energy and how you use it as it comes in, because that's really the second piece of the puzzle around energy independence. But we'll take a look at what additional local power sources are. So some solar design considerations. Really what you want to make sure is that your home is powered the way you want it based on the time of day. So part of what we look at really is understanding, okay, what is the solar input coming into the house? And there's a lot of different calculations that solar companies put together to really help homeowners maximize the energy of the sun and make sure that they're getting the most bang for their buck. But once you get it into the house, really understanding, okay, how do we take that energy and make sure that it's being stored at a home battery level, and make sure that we're looking at how is that energy going to be consumed once it's there. So on one side, you can see this is a great example of a platform that Savant has that manages energy. And you can see in this particular shot, there's something called eco mode. And that's really what happens when all this energy gets in the house. How do you control it and maximize it? Which energy source, in this case, solar energy, battery, or grid, which one do you use when and how? And platforms like this really provide great insight in terms of daily performance, and also essentially allow you to take that energy and use it how you want, and just not on a fixated set of loads, which helps with sustainability and costs and a whole bunch of other things. So secondly, what we really want to look at is sometimes systems are undersized, and what we want to do is really kind of offset the utility build. But when they don't have, a battery to charge, it's not as beneficial as it would be if it were an optimized solar design solution that has a battery. So oftentimes when you see solar, there's not always a home battery that's been designed there. So, you're getting some backup benefits, but not the full benefit of what a microgrid would be. And then when you look at really oversized solar, sometimes there's too much energy coming in, and power needs a place to go. Absolutely. Especially when you have multiple sources coming in. But as you know, within the sun, some days it's cloudy, some days it's going to be really sunny all week, and there's a lot coming in. And really kind of understanding, all right, if that power needs a place to go, maybe excess will go to the grid in certain areas, maybe it won't. But we need to watch really the battery and the components in the house to make sure that it's designed well. And then there's AC versus DC coupled solar. So AC really is existing solar with dedicated inverters, which we'll go into in a minute. And DC is directly connected to storage, which has less conversions. Most systems that have been out in the market are AC. So the DC portion really is an important piece to really look at, because it provides a lot more power in terms of your energy consumption and ability to get off the grid. So professional solar design, we work with solar companies. We're not a solar company, but this is a great example of estimating solar performance, and any really good solar company has the ability to take a look at your house and look at consumption offset, lifetime bill savings, net cost, and estimated net savings over the system lifetime. A lot of debates around okay, is this accurate? Is it not? There's a lot of different factors that kind of come into really what the consumption offset would be and what your savings would be. The key is when you're here at this place, really understanding not just the solar, but all your energy sources, whether it be solar, generator, grid, home battery, and then how all of that is controlled. So this really has been a popular place and a great growing home segment, but it's really just part of that energy picture. And so our ability to really take the power of the sun and be able to utilize it more effectively leads into the design of the actual overall system. A second power source that is really popular outside of solar are generators. And fossil fuel generators, they act as a backup source, and they're very effective at kicking on when the grid goes down generally. Generators should be automatic, so they really should be utilized when the grid goes down. In some cases, automatic generators can be triggered by something called the inverter on demand using a relay control. But generally speaking, as you're looking at it, we're really looking at saying, okay, how does that automatic generator work with batteries? How does it work with the inverter? How does it work with the other energy sources to be really a piece of that puzzle? When we're looking for generators, they're sized for backup, as we talked about earlier. They're sized for those critical loads in the home. And once they're in and they're assigned those critical loads, it's done. There's no flexibility. And it's effective at doing that, which is great. But in terms of really getting to that next level of using energy, it's got a lot of different limitations. So great piece of the puzzle of home energy, but certainly just a backup temporary source for people, not a whole home source, and locked in for those critical loads. Electrical vehicles as a home backup. So this is a really exciting area that has been really growing for, I'd say, about 5 years. They started to happen. I think here we have a Ford Lightning possibly that's here. They were one of the first companies to really start to market how your electric vehicle battery can act as a backup to your home. So what that means is if your whole home goes out, right, and you have no energy, V2H, vehicle to home, that technology is not on all electric vehicles. So it has to be a specific feature that's called out by the car manufacturer. But those that do have the ability to essentially take the battery that's in the vehicle, and let's say that that battery is fully charged and the grid goes down, you're without power, that vehicle will have the capability to manage some of your loads, like keep your lights on for a little bit longer, for example, maybe allow you to utilize some appliances. So it's a really kind of like out there concept for some people, but it's really just a battery. Just like if this were to have this particular picture, let's say we were to have a lot of home batteries that are in this garage. We don't see a lot of home batteries here. We see some other technology here. But in this case, the vehicle is the home battery. And it's also, you know, essentially the power for the car. So that is what V2H is. So in terms of a microgrid power flow, this is, you know, a lot on one chart, but this gives you an idea that when we're designing around power, there's math and science involved, and there's multiple components. So as we look at different pieces and parts of this, we're essentially taking all of the different components and putting it down so that we have documentation which relates to how much power each device needs, when do they need it, how are they going to work together, making sure that they're interoperable with one another is really an important part of the design. So we've got incoming grid power here. We've got a grid AC combiner, which is here. And then the grid input, DC solar, and load output are here within the design. You can see that, you know, essentially we've got a 200 kilowatt battery backup. We've got another 200 kilowatt battery backup. And then we have an emergency. There's other pieces on here, like other pieces of energy. And you'll notice in the top right-hand corner, there's an emergency stop button and rapid shutdown. So some of what you might be thinking is, what if there's a fire or some other event that happens? Isn't that dangerous? There's a lot of different kind of regulations, and it's different by state typically, and sometimes by municipality. But in a number of cases, what will be required is an emergency stop button so that power can stop coming into these devices as needed. So I just wanted to call that one out. But this is the grid input, DC solar, load output feature. And this is the load AC combiner. So we kind of went through those three. A generator and an AC coupled solar are two other sources. So those all have their own specifications, right? Not all generators are the same. Not all solar pieces of equipment are the same. And they have really different specifications. So it's really important as we're looking at microgrid power flow that we understand exactly what the specifications are of the solar and the generator, and we're considering it as part of the whole so that we can make sure that it is designed as intended. So that is a lot of the technical stuff, which helps us get to what most homeowners care about, which is the microgrid experience and how do you control all this cool energy independence once you get there. And to me, that really is where the impact happens. It's great to have energy savings, but there's really nothing like being able to essentially, with your phone, to be able to turn anything on and off, create scenes that are away mode or eco mode, and we'll look at other different scenarios as well. Like, for example, when there's going to be a storm, how a microgrid type of solution can really arm you for that to make sure that you're ready for it. So we've got holistic solutions that we talked about, which really are multimodal. And then we've got other solutions on the market, which are really, I like to call this like, it's almost like a Franken home is what we call it, when people have a lot of different apps, smart apps, individually controlling all these things. And most of what's on the market today, with some exceptions of the holistic solutions that we design around, really are like point to point independently, and things don't necessarily, they're designed together, but you can't control them together. And that's not much fun. So we like to design around the holistic solution. So we'll talk a little bit about this. So microgrid modes of operation. Let's pretend that you have the ability to essentially control all the energy in your residence through your phone in your pocket. So there's a couple different modes that we design around. So island off-grid mode, that is exactly what it sounds like. It truly is not using the grid or infrastructure outside of the home. It is leveraging power that is coming from essentially home batteries. The energy may be coming in through solar. It is essentially in an island off-grid mode. Now, for 99% of residences, they don't have enough batteries to really last very long, and the solar is not going to essentially be able to take the place of the grid. So this is a mode you might put in place through a scene or some other type of ability within the software so that you are off-grid and you are really just energy independent. Self-consumption eco mode really is kind of a step above that, in that, you know, you as an individual are proactively managing the energy consumption in your house. So in this particular case, eco mode, we use the self-consumption eco mode. We use the example that you could be, for example, going away for a couple days, right? You certainly wouldn't want to do island off-grid because you're not home. So there wouldn't be a need to kind of tap into that. But you would want to be able to make sure that you're not utilizing all of your appliances and energy, AC, things like that, at the level you would be if you were home, right? Because that would be wasteful. So self-consumption energy mode, if you were to click that on your phone, essentially that would make sure that all your different energy sources and what's using those energy sources are all set in an eco mode way, so that it's using the least amount of energy it needs to keep your house safe. Rapid charge store mode. This might be, I think, one of the coolest parts of really smart microgrid design and technology. So this is an example where, if you can envision, let's say a hurricane is coming in off the coast, or maybe it's not even a hurricane, maybe it's like an event that happened that wasn't expected to be so severe, but it came in and it was happening. Smart microgrid technology, what that does is essentially, because it's connected to the internet, it understands what's happening within the weather patterns, and it's connected to the National Weather Service and all the different alerts that are there. So if you can think of essentially a storm coming in, these systems are smart enough, assuming that the mode has been programmed, which we typically program a storm mode for all of our systems. It is smart enough to know that storm is coming. And what it's going to do is it's going to take your power sources. So that's grid, solar, maybe it's generator. And what it's going to do is it's going to rapid charge your batteries. And it's going to do that because it is predicting that you are going to need, 90% of your battery capability, because it is likely that there will be a grid event. It's likely there will be a power outage. So this is truly proactive management of the energy in your home. To me, one of the most exciting things, because in this case, this client has the phone open, right? And she's looking at it, but it's likely that she didn't have to even put her house in rapid charger store mode, because the system's smart enough to know there's going to be an event where we're going to be without power. We're going to make sure this house is ready with the fullest battery capacity that they can have. Lastly, power outage backup mode. So when the power goes out and you have, let's say you have 90% capability of that stored power, likely in a home battery situation, where do you use that power? Do you know how long you're going to be without power? Is it 3 hours? Is it 4 days? Right? You may or may not know that based on the situation and where you live and what the uptime is for your grid. This allows you, going back to the generator versus really a whole home solution, this allows you, the homeowner, to say, you know what, I'm going to turn on the television for 3 hours for the kids because I know exactly how much energy it's going to use. And I know that I'm still going to be able to keep my lights on and my refrigerator with power for another 2 days, for example. So this is that scenario where if you had a generator, you're really just stuck with those loads that you identified when you had your generator installed. This is no more. This makes it so much more powerful because you can understand exactly how much energy usage everything within your house tends to essentially spend, even down to like the unit and circuit level. You know exactly how much it typically spends. The system knows that, and you're able to essentially put it in a power outage backup mode that enables you to save what you have for your home energy that's local there and until the grid gets back online. And it also allows you to make choices about where you want to use that power, not just critical loads. It's where you want to use that power and what is the trade-off. So very, very powerful is this really the user experience piece. The parts and pieces of the system, the design, critical. At the end of the day, this is where the rubber meets the road, which is what is the end benefit for homeowners and how is it controlled. So homeowners really care about a couple things. They care about power flow. They care about, live consumption. I would encourage you, if you have not looked at or had a system where there's live consumptions, it's really, really eye-opening. I'll give you a great example. I put a system on my house 3 years ago. And so all of the different loads in my house, I'm able to see how much it's costing me. So if you can imagine that you, let's say you've got some holiday lighting up, right? We know exactly how much that holiday lighting costs us on a day, minute, hourly basis. And it's really powerful to be able to understand really where is this energy money going? You know it when you've got live consumption and energy insights, and therefore you're able to manage that. And we talked about time of use earlier in the course. That's one example of how you can use energy insights to really drive down your costs and energy consumption and use it more smartly. Then really top consumers. And this is like, where's the money going? Where are the kilowatts going? In this particular case, you can see in this middle portion of the slide, you've got HVAC, lighting, and this Savant equipment, which is the control system for this system, and outlets. And you can tell exactly who the top consumers are, and you can drill down. So if you're looking at lighting, for example, you can see, all right, is it my teenager's room? Is that like 150 watts of the 350 watts? You'll be able to tell even at the device level, where is this energy consumption going? Energy history is really fantastic to be able to see. You can see how costs and energy usage change over time. And then lastly, not everybody wants to be, this is a very cool view of your energy in your home, right? But not everybody wants to be in it all the time, right? So being able to have notifications, I think are really powerful. We talked a little bit about having automatic scenes. So if there is a storm event, for example, setting up the smart home control system so that if there is an event coming in, you don't even have to worry about it. You know that your home is going to be prepping the power for what might be an impending outage. So notifications are really fantastic and important to homeowners as well. So what is the one question every homeowner asks about a home battery or microgrid? How long is the battery going to last, right? There's a lot of different conversations and a lot of different people, maybe experts in this area, may not. The answer is there's a lot of different components for it. So really, how long are they going to last? It depends on what the appliance is, what the use is, what time of day it is, right? How long it's being essentially run, whatever it is. What do you have existing stored locally that is part of that kind of energy bank that you have? What time of day is being used? So there's a variety of different things in terms of being able to predict, okay, how, if I buy 2 home batteries of a particular size, how long is that going to last me through? It depends. And a really good example there is, for example, if it is at the height of summer and you're in a warm climate, guess what? If that grid goes down, right, that battery is not going to provide the same amount of time usage than if it happened during a relatively mild part, because your air conditioning is probably being used quite a bit during a heat wave. So that's a really good example. So it depends. The key is within a microgrid and a smart energy system, the homeowner is able to scale back and manage that energy. And that is really a very, very powerful thing. So really, we went through some charts that might have looked like really overwhelming. Maybe they did make sense to you. At the end of the day, we really approach it through simple specification. So you have to start with a minimal package for electrical service. We look at really what are the peak and average load that the particular property has throughout the year. We look at scaling inverters to really meet the profile of the home. So as I mentioned earlier, it really is a custom design based on the property. And then from there, we want to make sure we've got battery storage, but then be able to scale that battery storage so that when the home goes off grid, whether it be intentional or by design, that essentially it is the right size for that particular residence, and that also that it meets code. And in some cases, code is different depending upon where you are at in the country. So for example, there are some requirements based on where the battery is located. If you have a battery that is outside of the residence versus in the garage versus inside the home, there's different kind of levels of how much kilowatts those batteries can provide. So those are the type of things that we look at. And here's a good example of sizing for electrical service. So, in this case, a microgrid interconnection device, MID, allows the home to disconnect from the utility. That's what enables the microgrid. But we need to be able to match the incoming service that originally was being provided by the utility. So for example, a 200 amp service would equal, in this case, 2 100 amp inverters. A 400 amp service would equal 4 100 amp inverters. So, we also talk a little bit about pass-throughs and what that means to kind of bypass an inverter and feed directly into the home. Not all inverter and battery solutions offer full pass-through, so that's something to consider as well. And this line at the end, I think, is really important. It says off-grid output is the amount of power the inverter can supply when disconnected from the grid. And this can really incorporate power from the battery, but also other local power sources like generators. So that's really how we start when we're looking at sizing. Average and peak performance consumption. This is a great calculation. You want to start with really what is the monthly consumption of this particular property, and you can find that on your home utility bill, right? So you're going to take that. In this case, it's 1353 kilowatts. You take that and you divide it by the days in the particular month for whatever month your electricity bill is. Divide by the hours in the day, and then you're going to get your average consumption. So in this case, it's 1.82 kilowatts is the average consumption. You take that and you multiply it by 2.5, which is typically when people are looking at peak consumption, those peak hours of energy usage in the evenings where it's more expensive. Typically, it's at that 2.5 rate. So you know that your estimated peak consumption is going to be 4.55 kilowatts, right? So as we look at satisfying peak loads, Scale inverters enhance the output. So in this case, going back to the original example, we had 200 amp service with 2 times 100 amp inverters. Reviewing the last 12 months, the utility bill for that, what is that power peak usage? If not, use the 2.5 average power usage we used on the previous slide. And you want to make sure that really the peak usage is covered by the capacity of the inverter, because if it's not, it's not going to be able to satisfy that peak load. As we look at estimating off-grid runtime, which is that question around, okay, how long is my home battery going to last? And how long is my, off-grid, how long is my off-grid runtime? As we mentioned earlier, there are a lot of different components as part of that. But we look at really dividing the storage by average. So if you've got essentially 40 kilowatts and you're taking that 1.82 kilowatt calculation that we had earlier, you're really looking at about 22 hours of backup, right? But again, like that 1.82, if I go back to, let's see, this side here, this is the average consumption is 1.82, not the peak consumption. So that's something to consider. But you generally will have about 22 hours of backup for this off-grid runtime. When we factor in load management and look at really runtime calculations, what we're really trying to understand from the client is, what are the things that are most important to them? Every individual family or individual in total lives in a house a little differently, right? So understanding what the essential loads are as part of the design consultation is really critical. And generally what we want to do is we want to demonstrate, a 30% load shed. And a load shed, what that means is if we have, let's say we have 100% of our house and then the things we typically use up and running, we're going to take 30% of our energy that's not important to us, and we are going to go ahead and shed the load, which means that we're going to proactively manage whether or not it's being used or not. So in this case, for example, we might take a look and say, all right, if there is a grid outage situation, we are going to, based on that client input, we are going to automatically shed 30% of the load of energy loads that just aren't important for that particular individual or family, so that we can maximize those 22 hours of battery life. So if we're to do that, like let's take the previous scenario and recalculate what our uptime is with load management, then we're really looking at 1.82 kilowatts, which is the full load, times 70%. That's what we want. So we want a 1.27 kilowatt energy consumption there. So in that case, we're really upping our backup time from the 22 hours, because we've shed 30% of the load, to 31.5 hours of backup. So that's some of the powerful things that can be created and designed with systems like this versus kind of traditional energy, whether it be solar coming in or generators. It's really about how do you take this energy and maximize its output for the person in the house. So if we look at estimating off-grid runtime, this is a whole home backup example with 400 amp service. We're going to start with energy storage capacity. So in this case, there's 4 inverters, 100 amps, and you're calculating to an 80 kilowatt number. You review your utility bills for really average use across peak seasons. You're looking at 10 kilowatts, and then you take that and you divide it and you get 8. So performance in this particular example can be extended through that base off-grid design they have by adding additional storage, adding solar production, adding smart load management that enables you to shed loads during times when it really makes sense. So essentially what this gives you, this 8 hours, is your baseline for this particular design. And then you can add and extend performance with additional battery storage, solar production, and technology load management. If we look at energy storage placement, I mentioned this a little bit earlier. Installations need to be permitted, and really a lot of the residential building codes are local, and there's fire codes as well. So you really want to make sure that your authority having jurisdiction, you've contacted them, they understand the work being done, typically always permitted work. Your local jurisdiction may have additional requirements for you, and they may have situations where they will or will not allow certain things in certain places. So it's important to really understand that. This is from the NFPA, which is the National Fire Protection Association, who has done work in terms of permitted location and sizing for energy storage, which is really home batteries. So in utility closets, storage, or utility spaces, the NFPA says, all right, really your maximum storage energy there is 40 kilowatts. For garages and detached structures, which are probably the most frequent use of home batteries, you're looking at double that, 80 kilowatt hours. And then exterior walls and outdoor insulation also have 80 kilowatt. So why is that the case? Well, I mean, if you have an event with one of these batteries, it's certainly not inside, right? So in the case of, like, besides the garage and detached structures, it's not part of like the actual main residence. So utility closet storage and utility spaces have half as much maximum stored energy allowed for that reason. So it's really common sense that they have that, just to make sure that they're not putting too much inside the actual residence, and that most of it really is, they're encouraging garages, detached structures, and exterior spaces for it. So if we talk about smart load management spectrum, there are a couple different parts and pieces. One is smart breakers, and these are essentially proprietary panels. You can start small with them, so you can, at the circuit level, be able to manage certain loads, but not all of them. It gives you basic monitoring and control. So this is really, if you're looking at kind of like just starting to dip your toe in it, smart breakers is a good part of the puzzle. Some of them require smart modules and smart panels and are more integrated than others. But generally speaking, most smart power systems have some sort of breaker or module element to it. The smart modules are standard to an electrical panel, meaning that they clip in, and they are agnostic to the different types of panel. Generally speaking, you can start small. So much like the smart breakers, you're really kind of, you can start with just 3 or 4 loads, but you can take over your entire electrical panel and really have individual circuit level control. So you can imagine if you were in your living room and you had your entire electrical panel with smart modules on it, you could sit from your couch and literally turn on and off the power of everything in your home, whether it be an individual plug or an appliance. So smart modules are highly scalable. Smart panels essentially enable you to give some smart capabilities. It can be a replacement to an entire standard panel. They tend to be fixed in size. They're limited to 200 and 400 amps of service, which is a little bit limiting in that, you know, certainly there are homes out there with 600 amps as well. And it gives you circuit level monitoring and control similar to smart modules, and much better than smart breakers, which is really kind of basic monitoring and control. And then really like an integrated system really integrates with the inverter and has fixed outputs for backed up versus non-backed up loads, and limited scalability and control. You're not going to have the scenario where you're able to truly have the flexibility to be able to have your loads backed up or not backed up like you would with a smart module type of system. So that is very similar to generator. You pick your critical loads and you're kind of there with it. It's not a lot of flexibility. So there's really a spectrum there of ability, and they're not all the same. So if we look at practical load management as we kind of start to close this out and bring it all together for you, you want to be able to design around on and off grid flexibility, right? So we've got, in this case, grid power coming in. We've got on grid. So when we are on the grid, we've got a full service pass through to the home. When we're off grid, we've got 12.5, in this case, kilowatts coming in. So we've got home battery system, which is this large white item here that's next to the grid power. This happens to be a Savant home battery system. We've got communications and really the smart elements of being able to have the app and being able to manage loads in the load manager piece, which is essentially a computer really kind of taking all the inputs and outputs and making sure that they're going to be able to be used by the homeowner. The smart load center really is that electrical panel, which is now smart. In this case, there are a number of smart modules on here that are managing each of the loads, whether it be outlets or temperature control or appliances. And so it's taking that full load and it's enabling you to have scenes, be able to work on and off grid, and able to look at all of the data that we looked at earlier in terms of what's being used when, how much are things costing. So that smart load center really provides you that visibility and transparency to where your energy is going in your home. And that's really practical load management. When there is a grid loss, we talked a little bit about automatic load shed within a particular transfer time. So in this case, what we have is we've got, when the grid goes down, we've got an oven and temperature control here. We've got a 12.5 kilowatt flex load that we've decided that's going to be part of this particular scenario when the grid loss happens. Flexible load management is another version of what we've been talking about, which is really embracing different needs. You know, for a smart load center, what we can do is we can have enhanced comfort, cooking and cleaning, EV charging, battery extension. So smart load centers here, within this scenario where we don't want all or on off load management, flexible load management says, okay, in this case, if we've got 12.5 kilowatts of flex load, this particular homeowner wants the things that are most important to them are enhanced comfort, cooking and cleaning, EV charging, and battery extension, for example, or the opposite. Maybe they're going to get rid of those and focus on other things. The ability to be able to have the flexibility is created really through this design and the smart load center. And if we look at maximum performance, so really just powering what you need, and we have out, you know, the grid is down, we have this ATS, which is automated transfer switch, we've got a generator, and we've got a load manager, but we have no home batteries in this particular case. We have a smart load center. Then really we're working from, instead of 12.5 kilowatts, we're working with 10 kilowatts flexible load. So in this case, what we may design around is that smart load center, which provides us all that flexibility, we have different things based on the design of what the homeowner wants during that particular scenario so that they can get what they want. And it's truly, truly flexible. So as we look at it big picture and we extend load management with smart home technology, everything really starts to come together. All of these devices require power. All of them will be off grid if there's no energy solution in that house. If there's no generator, no home batteries, things like that. Outside of this, you know, essentially, you're really looking at saying, okay, when is that grid going to come back online? And you're losing climate, you're losing security, you can't play music, you don't have the Wi-Fi, all these different items, right? So really through great design, you can pull these things together and be able to have an investment, an energy investment local for that home that works really specific for that homeowner. So as we wrap up here, here's some things to know. Pre-cooling a home in advance of an outage enables you to really have lower rates. So in that case, it really is that time of use management. So if you are cooling your home before it's really hot, and everyone else is saying, oh my goodness, it's hot, turn on the AC, you're paying less for that amount of money, amount of energy, right? So pre-cooling a home is actually a great idea because you're spending less and you're putting less tax on the grid because you're cooling it ahead of when it's really needed. So that's something to think about. And obviously smart thermostats, what you want to do there is really widen the set points, which is the high and the low, so that you can really reduce the up and down activity of kicking on the system, because when you kick on the system, that's what creates like an energy spike. Smart lighting, which has really been absolutely exploding over the last couple of years, is a fantastic way to really make sure that you're not wasting energy with lights on. You're able to really quickly eliminate that in areas where it's not essential. And dimming lights really can help save energy, but also is a nice way to improve aesthetics and create a nice vibe within your home. Automated shades are fantastic, manual and automated shades. I'm a huge fan of automated shades because they work even without people doing things, right? For example, in my kitchen, my automated shades rise at sunrise, they go up. At sunset, they go down. So I actually never even control or touch them because they just do what I need them to do. In this particular case, shades and blinds do one of the most powerful things, which is they're managing the sun. And the sun coming into a house is a huge heat source. And so being able to use shades and blinds when things are hot or when things are cold really put less pressure on your HVAC system and save money. And then appliances are becoming increasingly smart. They're trying to be essentially more energy efficient. Supercharging smart water heaters is a good idea. You can extend preheat and run cycles on ranges as well, which can help you. So this is an interesting stat on the right here. Entertainment. Did you know TVs use up to 24 watts of standby power? That's 567 watts per day per TV. For a larger home, if you have 8 TVs that use nearly 5 kilowatts an hour of battery storage per day in standby. So that means that the television appears off to you, but it is still getting a power current and it is still costing you money and consuming energy. If you have a load management and a microgrid type of setup in your home, you're able to really manage that more effectively. And we'll wrap up here with a case study of an off-grid property in Osterville, which really is designed for sustainability and energy security. Home size is 8,500 square feet, 600 amps of service. The whole home energy storage product for this particular case study is Savant Power Storage 20. And we've got local power generation. There's a 38 kilowatt DC coupled rooftop solar. There's some alternative power also coming in through a 100 kilowatt automatic generator, which has been existing. So those are really the energy sources, right? As we talked about earlier. For the load management portion, there are 300 managed circuits, everything from HVAC to geothermal, appliances, lighting, AV network. EV charging, there's 2 Savant level 2 chargers, providing 50 amps and 12 kilowatts each. And for the smart home, there's lighting, shades, climate, cameras, and audio, video products. So as we look at the system performance of this design, on average, there's 16 kilowatts, the peak 25.5 kilowatts. So the average with EV included is 40 kilowatts to 7.5 hours with 16 kilowatts for full load. So at the end of the day, when it gets to like 15 hours, 8 kilowatts for essential and 136 kilowatts for the average day. So what that means is, if you are essentially looking at peak, or you're looking at how many hours am I going to have at 16 kilowatts for a full load, it's 7.5 hours. If I'm using 8 kilowatts in an essential mode or scene, then I've got 15 hours. An average day is going to be about 136 kilowatts that's being utilized for the solar portion of it. So all of that is taken into account as the system really kind of comes together. So how do you start? really understanding the true motivations of the client. Is it energy security that they're interested in? Is it sustainability? Understanding the economics and benefits in either case is important. Collecting the right information for the proper design, property location, electric service and large load requirements, the load profile of the home, which we went over a little bit in this course around the mathematic calculations that help you get there. Support with utility bills, floor plans, electrical and load schedules. Those are all really, really important pieces of designing around this sort of system. And then the electrical infrastructure plan, and definitely consulting with a power professional early in the project, especially if it's a new construction. The earlier, the better. There might be some interaction that needs to happen with permitting, and we talked about the authority that is based where that person lives and who's going to need to be kind of advising on that level. And then just the design, all the different parts and pieces and consultation that happens as parting to put this sort of thing together. So with all that, I hope that this was an informative course about microgrids. I want to thank you for attending. If you have any questions, feel free to reach out to me through our contact information. I want to thank Savant for providing this course. I'm working with AIA to essentially accredit it so that builders, architects, interior designers, and others can also earn continuing education credits as part of this. Thank you very much. I hope you have a great day.